Figure 2 represents two glass flasks P and Q connected via a tap. Flask Q, volume 1 times 10 to the 3 centimetres cubed, is filled with ammonia at 102 kilopascals and 300 Kelvin. The tap is closed and there is a vacuum in P. That means there's nothing in P at all, no particles, no molecules, nothing. We've been given the gas constant. Calculate the mass in flask Q. Now we've been given all these numbers and the gas constant. We've clearly been asked to use PV equals nRT. We need to rearrange that because we're trying to find mass. So to find mass, what we're going to do first is find moles by rearranging PV over RT. And then we need to put everything in the correct unit. So pressure, 102 kilopascals, needs to go into pascals. Volume, 1 times 10 to the 3 centimetres cubed, needs to go into metres cubed. Now that was a bit tricky because 1 times 10 to the plus 3 centimetres cubed. To convert to metres cubed, we need to divide by 1,000,000 times 10 to the minus 6. So if a plus 3 and now minus 6, 3 take away 6 is minus 3. So we're going to be 1 times 10 to the minus 3 metres cubed. The gas constant is given to us, 8.31, and the temperature was given to us as 300 Kelvin. So we type that into our calculator, and what we get off our calculator screen is 91456077. We don't need all that. We're going to give our answer to the appropriate number of significant figures, and if we look back at the data, we can see that we've got 3, 3, 3, and this number could be 1, 2 or 3, but given that everything else is 3, we're going to assume it's 3. So we could have just used 0.0409. Now mass of ammonia is the question. Mass is MR times moles, mass is Mr. Moles, so we add up the MR of ammonia, 14 plus 3 ones is 17. And we're going to multiply by our moles, and that's going to give us to 3 significant figures, 0.696 grams. Now in part 2 of this question, the tap is opened and the ammonia passes into flask P. Now do remember that that doesn't mean Q empties, it's just that some of the gas passes into P and some of it stays in Q. The temperature decreases by 5 degrees C and there's a new pressure. Calculate the volume. So we're going to rearrange PV equals nRT again for V. So V is nRT over P. The moles is going to be identical to our previous part, so 0.0409. Our gas constant is still 8.31. Our temperature, it says it's decreased by 5 degrees C, so they're checking on your understanding of that 0 degrees C is 273 Kelvin. When we were up here at 300 Kelvin, that was 27 degrees above 0. If we go down 5 degrees C, we'd be at 22 degrees C. We'd also go down 5 Kelvin. So they're checking that you understand that the degrees C and the Kelvin intervals are identical. So minus 5 degrees C is minus 5 on the Kelvin scale as well. And then we're going to divide by the pressure, and they've given us a new pressure of 75 kilopascals. Remember to turn that into pascals. We're going to type all that on our calculator. Now, because we've got our moles as a 3 significant figure number, we're going to get slightly different answers depending on how much we've rounded. So I've kept 3 significant figures and I'm getting 1.337 times 10 to the minus 3 metres cubed on my calculator. Now remember that this is the volume of P and Q combined, and the question wants the volume in P. So I'm going to minus the volume from Q. Now the volume from Q was given to me in the first part of the question. It was 1 times 10 to the, and remember we converted it into metres cubed, minus 3 metres cubed. So if I subtract that on my calculator, I'm now getting 3.37 times 10 to the minus 4 metres cubed, but the question wants it in centimetres cubed. So I'm going to re-multiply by 1,000,000, 1 times 10 to the 6, to get 337 centimetres cubed. Now this is the number you get on your calculator if you're using 3 significant figures throughout your calculation. Because of different rounding errors, the exam board would actually allow a range. They're allowing a range from 310, which is quite low, down up to 342. So that is the allowable range of answers.